So girls, I gave you a simple principle that we always do corrections for the question that is given, but there's no way one can do correction when you have not tried. So we are deriving the maximum height we are deriving the range, formula for range, and then we also looked at maximum range. Maximum range, we gave which condition? What was the condition for maximum range?
Condition? The value of sine theta should be maximum.
Should be maximum. And that is achieved when?
When
Theta is 45 degrees.
45.
When theta is 45 degrees. Then we looked at the time of flight. And we looked at time taken to reach maximum height. Time taken to reach maximum. So I looked at all these ones. I can't derive them again right now because now I want us to look at something. I wanted to begin with correction of that number, but I'm disappointed because none of you did better. But for the sake of Kathy and Daniela, only for the sake of those two, let me try to go through the question. So that was the question.
John, I have Daphne Miremba as well, and Nabwire Ruth Mercy.
Daniela, what was the question? You was what?
25. You was 25.
You was in? You was in?
25.
And then our angle was in? Our angle was 60 degrees. So I think you can see the diagram. When they ask, for example, time, let's start with the maximum height. Which equation are you going to use?
Like the final equation or
No.
that?
The other time I advised you that don't quote the formula. We can work out these things right from the basic equations of motion. I don't encourage you to cram, because when you cram the other formula, you can forget something and then you lose all the marks. Let's start from the basics. We start from Original
S is
equation
equal to
S equals ut plus a half h squared. We can start from there already. Then from that, we can start putting our conditions. In fact, I can first state for the three equations because S equals ut plus a half h squared and v squared equals u squared plus 2s. So even when they ask for the maximum height, they ask for the range, the time taken to reach maximum height, the other derivation that we derived. Normally the question comes asking you to derive that equation. But when it is a numerical question, start from the three equations of motion. Then we shall just substitute and get our answers. So it depends on what we are asked. For example, if we are asked for maximum height, which equation has displacement? We have this equation and this equation. Then you ask yourself, which one is going to be easier? This one has time, the second equation. It means to use the second equation to find h, I shall need time. You get it? But this one doesn't have time. And we can set a condition for maximum height. For maximum height, final velocity is 0. So you realize that if I use the third equation of motion, I shall find the answer easily, even without having the value of time before. I don't know whether I get what I'm saying. So I'm trying to mean that when they ask you to find maximum height, time of flight, always start with these equations. So for maximum height, I've told you that this one, where there is S, we put capital H. Where there is S, we put capital H. But for equation 2 requires you to be having the time, which is the time of flight. Equation 3 can give you the maximum height without hindrances, any other variable that is unknown. So, and that's why from these equations, if I'm asked to find the maximum height, I shall begin from v squared equals u squared plus 2as. So at maximum height, call it capital H. The velocity at that point is 0. The velocity at that point is 0. Then you substitute in your equation. 0 equals u squared plus 2. This becomes the minus 2bh. So from here, don't go further in deriving the equation. It's solved. Just substitute it because now you have the initial velocity, which is in 25 squared minus 2. Acceleration to gravity 9.8. Then times h. I use 9.8 if I'm not asked to assume. But if in the question they say assume g to be 10, then you use 10. Is it okay?
okay.
So from here, I can find my h as this 25 squared crosses this side, becomes a negative, then you divide by 2 times 9.8.
Yeah, 31.8878. 78.
887 meters.
Excuse
Yes.
on the value of initial velocity,
Since the object is signed at an angle, isn't it supposed to be you sine?
Forgot to resolve. This one is projectile motion. Sorry. This one becomes 0 equals u squared a sine. Vertical motion. Sine squared theta minus 2b h. Like that. Thank you so much, Gift. We have to resolve this u for your information. We have to resolve the u. U alone becomes u sine theta. So this one becomes u was 60, u was 25, sine theta is 60, out of it squared minus 29.8 h. So 0 becomes 25 sine 60, the whole root squared, you get what?
$468.75.
68.05.
75. It is 0.75.
0.75 minus that 2 times 9.8, you get what? 19.6?
Yes.
Yes.
19.6 h. So our h becomes 486.75 divided by 19.6. And you get what?
23.9158.
9158.
915.916. Something like that.
So
I see the procedure.
Even
Yes.
when I use the direct formula.
Pardon?
When I use the direct formula, I also got that. When I use the direct formula, I was also able to get that.
Yes, of course you get the same answer. I gave you the difference. Should I repeat? Yeah? I told you that the direct formula, the reason as to why we derived it, the question shall ask you to derive it. But when they say they give you a numerical question like this one, they have given you the angle, they have given you the value for you. No need for quoting the formula, because one, you will lose marks. You lose some marks because some marks are distributed following this procedure. Two, you might miss out something in the formula. For example, where there is 2 theta, you might put only theta. Then you get everything wrong. But when you come and write it from the beginning, you realize that if you have made a mistake, you can easily identify it. Is it okay?
Maybe John,
Yes,
before you proceed, I think the formulas the girls are trying to quote, if I'm not mistaken, some could be in the rope book. Some could be in the rope book, and what you are telling them is to help them be on the safe side, because at times when they are quoting these formulas, they leave out some parts. So it is advisable for them to know how to move from the basic principles and they progress onwards. Though if someone can quote it rightly, it's implied. It's implied, and they can get a mark. Okay, though it's risky to some that are not good at, quoting those formulas well, right? And then the other thing I had some of them saying at times they might bring a different data, not necessarily theta. So let's not get used to saying theta. They might bring alpha, they might bring beta, So we just need to know that it's the angle of projection. So not all times we are going to be using theta. So let them know that there is that option also. They shouldn't cram that all times in projectile motion we shall be using theta. Okay, you can proceed, John.
Thank you so much. I think, girls, you have gotten that. Using a formula is okay. Using a formula is okay, but you have to be very sure that you are quoting the correct formula. You can reach maximum height. Time to reach maximum height. I can use V equals U plus EFT still for vertical motion. V is 0. So when V is 0, it means 0 equals result of U vertically, U sine theta minus dt. So when you reach here, you don't need to make it the subject, just substitute. 0 equals 25 sine 6t minus 9.8t. So t becomes
2.209.
2.21.
2.209. 209.
like that.
2.209.
Yeah, 2.2. Okay, 2.21 seconds. Then we go to.
No.
We go to. Time of flight, yeah. Time of flight, I told you the other time we use still vertical motion, ut plus a half at squared. When a particle is projected from point A and lands same horizontal ground, point B, this vertical displacement is 0. U becomes U sine theta, then times t. Our t now becomes the total time taken from point A to point B. I call it capital T, which is the time of flight, minus a half acceleration becomes acceleration due to gravity, capital T squared. So when you reach there, simply substitute. Our U was 25 sine 6t times capital T minus, this is 9.8 out of 2 capital T squared. So if I factor out capital T, this is 4.9. So the first value of capital T is a 0. First value of capital T is a 0 at point of projection. Then the second one, the second bracket, we shall have 25 sine 6t equals 4.9 t. So our t becomes
4.418. 4.42.
4.42. Is that okay?
Yes.
So let's go to the other one.
So teacher, which time did you find that first?
Eh?
What time were you finding in the beginning?
The first time was time taken to reach maximum height.
Oh,
Time
okay.
up to this point. Now we are finding time from here up to B. So you're going to realize that this capital T is twice smaller t that you obtained.
John, someone had
Yes.
their hand up. Okay. Okay, Nsibirwa Kathy.
Teacher, is it wrong if we just state that time of flight is twice time taken to reach maximum height? Remember that point.
It is
Yes.
okay. It
Just
is
say
okay.
that.
Now that you got small t already, you can just substitute.
Okay.
We had another hand up. I think she has lowered it. Okay, you can move on, John.
The other one is range, horizontal range. Horizontal range, we can use our formula S equals UT plus a half AT squared, but we consider the horizontal motion using this formula. So horizontally, this S, I can call this S horizontally. Let me call it capital R for range. Then U, you resolve our U horizontally, becomes cos theta, then times. I'm calling it capital T because the time taken from point A to point B. We said horizontally there is no acceleration due to gravity. So my equation shall stop here. So now that I have all these ones, I just substitute. U was 25, cos theta was 60, capital T was 4.42. Our range becomes
55.25.
55.25. Is that okay?
Teacher, what does range mean?
What does it?
Range mean?
Range is the horizontal distance covered. Horizontal distance covered from this point up to where the particle is. For example, we have from point A, the particle landed at point B. So the horizontal distance covered is what we call the range.
Okay.
John, I think the girls need to put it into perspective. Range is usually on the same level as the point of projection. Eh?
Yes. Yes. I don't know that. Girls, do you get that? That particle should be coming from point A to point B on the same horizontal ground. If a particle was at a certain point, say this point, if a particle was at this point from the point of projection, then we will simply call this one horizontal displacement and then this one vertical displacement. You get that?
Yes.
Pardon, please.
If a particle was at a certain point, x, y,
Um, girls,
Hello?
yeah, we seem to have lost Mr.
Shall go.
We seem to have lost Mr. Bakayana. So we can give him a few minutes to see if he'll connect back. Yeah, but in the meantime, if there are questions that you want more clarifications on, we could be discussing as we get him back. And whatever is discussing, all these notes were shared on the Google Classroom. So I expect you to have downloaded that document by now, and you should have tried some of those questions. So are there questions you want us to be discussing as he tries to get back? Okay. John?
Yes.
You're back. I guess your network, you had gone off, eh?
Yeah, somebody was calling on the phone. It disturbed the network.
Okay, so you can pick it from where you stopped.
So I was saying that when you throw a body from this point, then to this very point on the same horizontal ground, the horizontal displacement, the whole of this horizontal displacement is what we call the range. However, if I want the position of the particle at any time t along the trajectory is this path. If I want the position of this particle at any point p, then I would call from here up to here the horizontal displacement just, then from here up to here the vertical displacement. Altogether?
Yes,
Yes,
teacher.
teacher.
Okay. So we have gotten the range. Supposing they ask for the maximum range. Supposing a question said that, what would be the maximum range in this situation? Maximum range, you quote u square out of what? Is it out of G? It's out of G, not so?
Yes, teacher, it's out of G.
So maximum range, we state our formula. Maximum range, 2 theta. You don't need 2 theta is 90 degrees, theta is 45, but you can simply say sine 2 theta is the 1. So R becomes u squared out of G, which is 25 R maximum, 25 squared out of 9.8. So that's how we will get the maximum range in case it was asked. Is that okay? You get what?
63.78.
63.78 meters. That is the maximum. That is the maximum range. Susan, you have any question?
No, teacher.
Okay, I want to continue. Yeah, we can try out that one very fast. We can try out this one very fast. I hope you can see it properly. Can you?
Yes, teacher.
Yes,
Yeah, you
teacher.
can try it out.
Yes, teacher.
Teacher,
Hmm?
so we are requesting you please read it.
That what?
Maybe John,
Read it.
can you read it so that maybe those who are using small gadgets like a phone could pick it?
Not so.
A particle is projected with a speed of 20 meters per second. A particle is projected with a speed of 20 meters per second. With a speed of 20 meters per second at an angle of 30 degrees to the horizontal. At an angle of 30 degrees to the horizontal. At an angle of 30 degrees to the horizontal. If it just clears a pole, if it just clears a pole 15 meters high, if it just clears a pole 15 meters high, calculate Roman 1, the distance from the pole to the point of projection. The distance, in fact, here add the word horizontal distance. The horizontal distance from the pole to the point of projection. The horizontal distance from the pole to the point of projection. The horizontal distance from the pole to the point of projection. Can you try it, or we try it out together?
Teacher, is
Teacher,
that
does it
correct?
land on top of the pole or it passes the pole and lands somewhere else? Mm.
Okay. I want to rub off.
It's okay.
It's okay.
So in that question, when they say that a ball is projected at an angle of 20 meters per second, and then just clears the pole. Just clears the pole means that it is passing just on the highest tip of the pole. So it's okay to stop your diagram at that. The rest of the information beyond is not necessary. I shall show you where the information after the ball has passed the pole. There are some questions where we are interested in the distance after the pole. But when they say it just clears the pole, and then we have no more information about what happened, that maybe it fell 20 meters away from the pole, the diagram can stop here. At the point of clearing the pole is the point when it has just touched the tip or the highest point of the pole. So at this point, we could have, if this one is our horizontal displacement, then this would be the vertical displacement. So this point here would be X and Y. All together.
Yes, teacher.
The rest out together.
Yes.
All together.
Yeah. So when
Teacher,
they say, yes.
So here the displacement is not zero since it has not landed like at the ground again.
Yes. Yes. Displacement. You get it, yeah? So our diagram stops at a point when it is just clears at that very point when it has just touched the highest point of the pole. And then the diagram can stop there. Then horizontally, we had said that x, we derive x as u cos theta times time. You remember that? For horizontal motion. Okay. We use our formula S equals ut plus a half at squared. And we say that when we are dealing with projectile motion, we divide the motion into two. We consider vertical. Vertical motion, what are we going to have? Can I have one person? Kathy, what are we going to have vertical motion here? S becomes what?
Why?
Why?
U becomes
U sin theta.
U
U sin theta.
N times a T
30.
minus a half, A becomes D, and then a T squared.
Square.
Is it okay? So I can even substitute. My y is 15 equals U as what? 20 sine 30 times T minus a half times 9.8 T squared. You can call that equation 1. You can call that equation 1. I'm calling it equation 1 because I've not yet seen how it is connected to what we are looking for. What we are looking for is the horizontal displacement from the pole to the point of projection. Do you get my point, Aditya?
Yes.
Aditya, you have a question?
No, I don't.
Yeah. So I'm calling this one equation 1 because it is not yet connected to what I'm looking for. Me, I'm looking for x. Then I go to vertical, I go to horizontal motion. Horizontal motion using the very equation, S becomes horizontal distance covered. S becomes x, U becomes U
Equals cos theta.
Time,
That's why it stops, because it does not have an acceleration in the horizontal direction.
Yes. So I can substitute x equals the U as 20 cos 30 times t. Do I have time? No. So remember, this time in this equation 1 was the time from the point of projection up to this point. Still, we are finding x horizontal distance covered from the point of projection up to this point. So the time we get here qualifies to be used in this second equation. Do you get that?
Yes, teacher.
So can you find t in the first equation? This is 15 equals 20 sine 30, I think that is a 10t. This is minus 4.9 t squared. So this is 4.9 t squared minus 10t minus 15 is equal to 0. What is t?
One 1.02. 1.02.
1.0.
1.0.
02.
1.02. 1.02.
This one is a 15. Let me see. 4.9 equals minus 10 equals 15 equals. Yeah. So we are getting T as 1.02 seconds.
John, I
So my
see. John, I see someone's up. Ketra, I don't know if they have answered your question.
Ketra was asking what?
Her hand was up, but she has lowered. Maybe you've answered it. You can continue.
Teacher,
Ketra, what was your question?
I've tried using the bulldozer method to find the value of t, but it's giving me the values of t as complex, not real.
Then you should have substituted wrongly.
No, even with a calculator, teacher, that's how it is. They're giving us complex results, not real.
Are you sure?
Jamaica, I have
They're
Geometric.
Yes, I can see they are
T
complex.
is complex, it's not real.
Okay, they are complex. I should have used a different value, like for that velocity or for the angle. But I just want you to get the concepts. Yes?
Teacher, I think we should use the first equation of motion because it gives me a straight value of time.
The first equation of motion.
Yes, because if we say,
Okay.
because when I tried it, I said,
yes, Theodore.
I see Taritha Sam's Ashare's hand up. I don't know. Maybe can hear from her.
Okay, you tell us.
Teacher, I suggest we use the equation of trajectory. You wouldn't have to find time and you just substitute, you still get the answer.
Okay, girls, I think one thing we need to note here, we need to move one step at a time. Okay, because Mr. Wakana has been trying to show us how we can use the three equations of motion. We modify them to suit our scenario of projection at an angle so as to work out whatever the question is asking. So let us try to first of all play around with the three equations and then we see if we can reach at an answer. Okay, because equation of a trajectory is a combination of the two equations I'm seeing here, the vertical displacement and the horizontal displacement. So we shouldn't, just hear the word equation of a trajectory and then we get excited. It is basically a combination of vertical displacement and horizontal displacement. So there is no big deal. That one aside, John, what was the question asking?
The question was to find the horizontal displacement x.
Horizontal displacement x. Do we know the time taken to move that distance? Have they got it?
We had to first find the time.
Okay, and the information given in the question is giving us values of t that are not real. Yeah, that means the values perhaps we are substituting in could be having a problem because
that's where the problem.
Yeah, the people who are telling us to use the first equation, do we know the vertical the vertical velocity at that point? Did they tell us it was the maximum point? Unless if we assume that that particle is touching that, was it what was it? Was it a vertical pole?
A vertical pole.
Yeah, if they tell us that that vertical pole was equivalent to the maximum height, then we can use the first equation. Or alternatively, we can assume, okay, we can assume that that vertical pole is equal to vertical height through which that body is going to move. That's when you can use the first equation. Otherwise, if the question is open, there are so many possibilities. Okay, I see some hands up. Can you hear from them? Can we hear from Raji?
Maybe let me first explain this. Girls, listen.
And maybe
I've
John,
given the question.
John,
I've given the question values. I've just assumed that 20 meters per second. The question is not part of those ones I gave in the handout. I've just assumed something that can guide us on how to get the horizontal displacement. I've just assumed the 20 meters per second, 30 degrees, and then the vertical height of the pole.
Maybe John, I don't know if John, I don't know if the girls are, I don't know if the girls are, I hope they are arranging the equation well to come up with a quadratic equation, because the way you put your signs also matter, okay?
No, I've also gotten this one. I've also gotten 1.02 complex.
Okay. Can you hear from these hands?
My point is,
yes,
let's not focus on the complex, because a question that is set in an exam, we shall not have complex roots. I shall have worked it out first to ensure that we don't come up with complex roots. You get it, girls? The major idea of this work is to show you the steps through which we can get the horizontal displacement, and this is the correct step. So it was a matter of using a different value in the question for velocity maybe or for vertical height to avoid the complex answer on that time.
Okay, John, can we hear from the two hands? I'm seeing Davina, Nakaiza, and Ketra. Can you hear from Davina first?
Teacher, what if we just skip the finding time and then we get x by substituting? Make t the subject in the second equation and then in the first. And then we just...
Okay. Whether you skip t or whether you get t, even if you took it, you made t the subject and you took it in the other equation, you'd still get an answer which has questions.
Yeah.
So it's not all about whether we are taking t the other side or they are calculating it first. I think the values we are putting in have a problem, or else we make an assumption.
Yeah. Let me try to give you something that can avoid the complex roots. This is 4.9.
John, I think actually our time is well spent, so we should be winding up.
Okay.
Yeah. Mr. Nika, I see you in. Just give us a few minutes so that we wind up.
Okay. So, girls, as we are winding up, don't be worried of the complex root. Just get the steps that we have taken. The steps are very correct. The problem was with the question where I used one of the values, maybe for velocity, maybe for angle, that I should have used another one to avoid the complex root in the final answer. So that one I apologize, because the truth is I've not done it before to ensure that I don't give you, it doesn't give us a complex root. But this is the correct procedure. Find time. After finding time, use it in this second equation to find horizontal distance. Simple as that. Is that okay?
Yes, teacher.
Yeah, this is the correct procedure. Find type using exactly the same procedure. In a question set in an exam, you will never get complex rules because we shall have made sure that the values that are used in the question can't take you to the complex rule. So you'll find time after time, then you can find the horizontal distance covered. So we can stop there for now.
Okay.
Question you inbox me on WhatsApp, I let you understand this one better so that we don't go to the same thing again when we are starting the lesson next time.
Thank you, John. I can see in the notes you gave them, there are trial questions.
Yeah, and the examples.
Yeah, can they try to go through that work so that
Yes.
it helps them understand the concepts? Maybe next time when we are doing this, we can pick from these questions that you're having. Yeah, I hope they are well modulated so that we don't waste time, getting answers which are complex kind of.
Yeah.
Okay. Thank you, John. Thank you, girls. I guess we'll meet next week, and next week is going to be, I guess, our last lesson for online classes. After that, we are going to do some kind of online exams. So you need to start preparing for that. We shall set for you exams which you can attempt using some kind of quiz. So you can work it out maybe in your book and then just tick off the correct answer. So we might not ask for all the steps because of the nature of the running we are having. But the most important thing is for you to understand how to do these numbers. Okay, you need to know how to move from step to step until you go to the final answer. So for now, it's a bye. We shall meet next week on Tuesday.